Hi and welcome back to Batee.com. Today we're going to talk about rebuilding the 90 through 96 Corvette C68 electronic climate control system. We're reshooting these videos because some time has passed and there have been some changes to the kit of parts that we offer and the installation procedures. And also we've got some experience rebuilding these for the past few years that we'd like to share with you. As we can see, we're getting a 3 dashes display on the LCD for the controller unit. This is fairly typical, and it usually means that there's a problem in the programmer that we need to rebuild. We also see that not all of the backlights are turned on. We see some backlights behind these switches, but not behind these switches or the top row, and so we'll be addressing that as well. Here we see another form of the problem display. It's completely blank. The backlight is lit, but there is absolutely no display on the LCD. And again, this usually means that there's a problem with the programmer module. In this video, we'll show you how to rebuild and test the programmer module and the controller module. You can go to Batee.com to purchase the parts. You'll find a link in the description. There are 6 screws that hold the case on the controller unit. Those screws are located here and here and at each of the 4 corners of the unit. And I'll just remove those with a 3/16" nut driver. Set them aside. We'll notice that the shorter screws come out of the screws next to the connector. The longer screws come out of the plastic housing down by the faceplate. We'll set those screws aside and we'll carefully remove the back cover. Set it aside. Here we see the controller with the faceplate removed. To disassemble, we'll lift this white connector away from the logic board. Then we'll gently pull the faceplate away from the logic board. We'll set it aside. We'll lift off the white light reflector. We'll twist the bulb and pull it out through the bottom of the board. Now, the first thing we're going to do is replace the power supply capacitor. This is an electrolytic capacitor. They tend to leak. It still has the factory capacitor in there, so we're going to replace it. We're going to heat each terminal of the capacitor and slowly rock it to the side. Again, we'll heat that terminal, rock it the other direction. Repeat that a couple of times until the capacitor comes out. Alright, next we'll heat the pad. We'll use our vacuum solder removal tool to pull the solder out of that hole. We'll do the same thing for the other hole. Okay, if we look at the board, we'll see a marking on the negative side. We look at the capacitor that came out. This is a 22 microfarad capacitor. So we're going to take the 22 microfarad capacitors that came with the kit and our wire cutters. We're going to cut one loose. We definitely want to cut this away from the tape. We do not want to pull it out of the tape and have to deal with the tape residue. If we look at the capacitor, we see there's a negative marking on one of the leads. It says negative and there's a big white stripe. We're going to place that in the board aligned with the dash negative marking on the board. Then we'll flip the board over, bend the leads apart slightly to hold them in place while we solder them. I'll go ahead and reset the focus. Do we need to? Okay. I think you got it. solder the new capacitor in place, we'll apply heat to the lead of the capacitor and to the pad at the same time. We're applying heat right where they meet. We'll feed in a very small amount of the new fresh solder and remove the heat. We'll go to the next pad, heat the junction between the pad and the leg of the component, feed in a small amount of solder, and remove the heat. Finally, we will use our wire cutters to clip the leads of the capacitor. Next, we're going to use some of my favorite product. This is called Deoxit. This is available at music stores. This is available at Amazon. And this is a contact cleaner. This is for improving electronic connections between low current contacts. We're going to spray some Deoxit into the faceplate connector. We're going to spray some on the LCD connector. We're just going to let the excess drain off. Finally, we'll put some on the wiring harness connector. A very small amount is all we need. We'll clean up the excess with a paper towel. We're definitely going to let this dry before we put it back together. Next, we'll remove the light bulbs from the faceplate. We're going to use a flat blade screwdriver. We'll turn the bulb about a 1/16 of a turn counterclockwise. Pull it loose. There are 4 of those bulbs in the faceplate. Just gently lift those out. Set them aside. We're going to take our 3/16 inch nut driver, remove the 2 screws on the back side of the faceplate. We're going to set those aside, and then we'll pull the faceplate circuit board up and out of this assembly. Next, we're going to remove the rubber switch contacts. We're going to leave the buttons in place unless you have a reason to clean them at this point. If the unit has seen a liquid spill, if the buttons are sticky and not moving freely, you might want to take this opportunity to take them out and soak them in hot water. These seem to be in good shape, so we're going to leave them in the unit. It's much easier to leave them in place than it is to remove them and replace them. So this is the faceplate circuit board. Some common things that go wrong are the solder joints at the faceplate connector tend to turn cold and lose their connection to the circuit board. And the other thing that can happen, again, if it's seen a liquid spill, is that liquid buildup can form on these switch contacts, which makes them not work as they should. The first thing we'll do is resolder the faceplate connector. I'll show you how to do that. Alright, that looks pretty good. We will apply heat to the junction between the circuit board and each pin. We'll feed in a very small amount of fresh solder, and then we'll remove the heat and go to the next connector. We want to make sure to keep the solder as low as possible on these pins because, again, they do have to plug into the faceplate when we're done. If any solder builds up higher up on the pins, you can take an X-Acto knife and scrape it away. Okay, after we've finished one side, we'll turn the circuit board over and we'll do the other side. So after we turn the circuit board over, we will refresh the solder joints on each of the joints on this side. We're making sure that we don't create any solder bridges, and we're making sure that we don't get any solder anywhere near the switch contacts, which you can see are the circular shaped traces outlined in black here. After we finish soldering those solder joints, we'll make sure the LEDs are lined up straight. We'll look at the board for any other problems. Finally, we'll take a paper towel. I'm using some 91% isopropyl alcohol. And we're just going to clean those switch contacts. I'm wiping them lightly. I am not scrubbing them or scrubbing them off of the board. All we're doing is cleaning them, letting the alcohol evaporate. We'll let this dry thoroughly before we put it back together. The black dots on the back of the rubber sheet form the other half of the switch contact. We're going to go ahead and clean those at this point. We'll use isopropyl alcohol and a clean paper towel. We'll push the button so that the black contact is proud, and we'll wipe it gently. We see we got a little bit of dirt off on that one. We'll do that for each button on the rubber sheet. We will let this dry completely before we reassemble things. Next, I'm just using some compressed air to clean any dust out of the faceplate assembly. Okay. We'll replace the rubber sheet. We'll make sure that the index pins in all of its corners and around all of its edges are in place. Then we'll gently reinstall the faceplate circuit board. Again, we'll make sure all of those pins protrude through the board before we start screwing anything together. We don't want to crack anything. This is 30-year-old technology. The board is fiberglass and it is fragile. And we're also sandwiching an LCD panel made of glass in there somewhere. So again, we'll replace the two screws. We'll tighten them gently with our 3/16" nut driver. Okay. And finally, we'll just test each of the switches and make sure they move freely. These feel great. Next, we're going to replace the bulbs. The bulbs in the kit do not include the plastic factory bases, so we'll need to reuse those. Be very careful with them. We're going to use an X-Acto knife, and I'm just going to gently lift the wires away from the plastic housing and pull the bulb out. Next, we'll straighten the wires out. We'll put one wire through each hole. We'll make sure that they're not both going through the same hole so that they don't short out. We'll use our needle nose pliers. We'll pull the bulb tight. Then we'll bend the wire off to the side, making sure that the wire goes into the slot pre-cut in the plastic bulb holder. Finally, we'll wind the wire around the side post and trim it flush. We'll do the same thing for the other side. When I'm doing this, I'm pulling it fairly tight just to make sure that that wire is flush against the plastic bulb holder. Okay, there we see the replaced bulb. We'll do the same thing for the next four. Okay, after we replaced all four bulbs, we will Reinstall them in the faceplate. The 4 short ones go into the faceplate. And again, we'll turn them about a 1/16 of a turn clockwise to seat them. After we reinstalled all 4 bulbs, we're just going to push down on the LCD wiring harness to make sure it's seated fully against the LCD panel. Next, we'll install the long bulb holder. We'll turn that about a 1/16 of a turn with a flat screwdriver. We'll replace the light reflector. Okay. We will carefully align the pins on the faceplate to the holes in the logic board connector. We'll make sure that we don't have a pin overhanging on either side of that black connector. We'll make sure that the logic board is seated fully against the faceplate. Then we'll replace the LCD connector. At this point, we'll replace the housing. We'll make sure that the logic board goes into the guides in either side of the housing. We'll make sure we're not trapping this wiring harness when we seat the plastic housing. We'll replace the 4 screws holding the faceplate onto the housing. Next, we'll replace the 2 shorter screws that go into the connector housing. And that completes reassembly of the controller unit. We're going to set that aside and work on the programmer. Next, we're going to restore the programmer module that you see here. The first step, we're going to just cut the factory tape. We're going to set the cardboard shield aside. We don't need to remove the vacuum lines from the plastic housing, but we do need to disconnect them from the solenoids. And I'm just gently pulling until they come loose. We'll do the same thing with the electrical connector. We'll lift it, move it aside. Next, we're going to remove the solenoid board. We'll do that with a 1/4-inch nut driver. We'll remove the 2 screws, one on either side. We'll set the solenoid board aside. We'll set the screws aside. Finally, we'll remove the 2 screws that hold the logic board in place, again with a 1/4-inch nut driver. Then we'll gently lift the board out of the plastic housing. Alright, here we see the 2 boards inside the programmer assembly. There are actually 2 versions of the logic board. The one in our programmer is an older style board. This is what a newer board would look like. We'll notice that the capacitors are in different locations, and they also have some different values. But regardless which board you have, the process is the same. These electrolytic capacitors tend to leak over time. Sometimes you'll see black charring at the base, or a resin that looks like a black tar. For the most part, these capacitors are 30 years old, and we know that they're just about all failing at this point, so I would go ahead and replace them all. We're going to start with the large capacitor. This is marked 100 microfarads. Regardless which board you have, the process is the same. We're going to start with a Sharpie, and we're going to mark the negative terminal on each of the capacitors. The negative terminal is shown by a white stripe with a negative sign on it. We'll just make a mark next to each of those negative marks to make sure we reinstall the capacitors in the right orientation. Next, we're going to start with the large capacitor. It's marked 100 microfarads. We're going to make sure we cut away all of the lead that's been touched by tape. We don't need the extra lead length anyway. We'll turn the board over. We'll apply a bit of heat to each of the terminals, and we'll rock the capacitor from side to side. We'll alternate terminals. Until the capacitor comes out. Next, we'll heat each of those pads. We'll use our vacuum solder removal tool to remove the solder. We'll make sure that we can see light through those two holes. And we'll turn the board over, and we will reinstall the capacitor with the negative lead toward the mark we made on the board. We'll bend the leads apart slightly just to hold the component in place while we're soldering it. We'll solder the component by applying heat to the junction between the solder pad and the leg of the component. We'll apply a small amount of fresh solder, and then we'll remove the heat. We'll do that for the other leg of the component, and then we'll clip the two legs so that they don't short on anything. Again, there are two board layouts. This is the board we're working on. This is what the other board layout looks like. The kit includes capacitors to rebuild either board. What we'll do is, one at a time, we'll remove the capacitor by applying heat, rocking the legs, rocking the can of the capacitor, till it falls free. Then we will use our vacuum solder removal tool to clean the holes out. We'll look at the component to see what value it was. This is a 22. So we'll cut a 22 loose from the tape. We'll install it with its negative mark toward the mark that we made on the board. Again, bend the leads apart slightly just to hold the component in place. Hold the component in place while we solder it. We'll apply some fresh solder and some heat. We'll trim the leads. We're going to do that for each of the other capacitors. Again, when we remove the capacitor, we'll note its value. When we remove the capacitor, we'll note its value. This is a 22. We'll clean out the holes with whatever solder removal tool you have at your disposal. If it doesn't work, apply a bit of fresh solder and try it again. It worked this time. We'll take another 22 microfarad capacitor and replace this one, making sure that its negative mark lines up with the mark we made on the board. We'll apply heat and fresh solder to each leg of the capacitor and trim its leads. Okay, and we'll do that for the last capacitor, which is this one. We'll use our vacuum solder removal tool. This was also a 22. This was also a 22 microfarad capacitor. We'll install it with the negative mark lined up with the mark we made on the board. Bend its leads apart. Apply heat to the junction between the solder pad and the leg of the component. Feed in a bit of fresh solder. Remove the heat and then trim the leads. So we see all 4 capacitors have been replaced. We're going to double check that their orientations are. At this point, we're going to examine the logic board for any issues. The first thing we're going to do is we're going to look at the contacts on the wiring harness connector. We're going to make sure that they're shiny and bright and that nothing looks corroded and that nothing is missing. It's fairly common for pin D4 of this connector to corrode away completely. The reason I think this happens is that the unit got wet at some point in its career, and electrolysis on the power supply pin just caused that pin to corrode away. If that's the case, we do have replacement connectors in stock. Alright, the other thing we're looking for on the board is do we see any diodes which have just self-destructed? There are multiple types of diodes on the board, so we don't want to start randomly replacing things, but if we see any diodes that have self-destructed, it's possible that an overvoltage or a reverse voltage jump start might have taken one of those out, and if that's the case, we have replacements included in the kit. I see no problems here, so we're going to go ahead and pass this logic board. The other style board has the same number of capacitors, 1 big one, 3 small ones. They're in different locations, and they're different values. If I look at this board, I see a 100 microfarad capacitor for the large. I see a 22 microfarad for the small one up here at the top, near this IC. But the other 2 are 39s, and that's the reason that we include those 39 microfarad capacitors in the kit. If the problem that you had with your climate control was that you saw a blank display, or you saw the 3 dashes on the LCD of the controller, this next step is likely necessary. The transistors that are used to communicate between controller and programmer module frequently fail. These are fairly small transistors. This is a new style board. They're located here, 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 and here. This is an old style board. They're located here, 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 and here. It turns out that this one's disintegrated. There are 3 leads on each of these transistors. We're going to use a regular soldering iron. We're going to use some tweezers. We're going to use an X-Acto knife for this process to remove them. I'm going to apply heat to the side with one leg, and I'm going to lift the transistor away from the board. Next, I'll turn the board around, apply heat to the side with 2, remove the component. Next, I'll use some solder braid and heat to remove the old solder. Once we've removed all of the solder, we'll take a transistor from the kit. These are fairly small parts. The process is fairly involved, so if you need assistance doing this, Batee.com has both the parts and experience to be able to help. We'll apply a dab of solder to one leg. We'll pick up the transistor, orient it, and heat that leg that we applied the solder to. That's just going to tack it in place. Next, we'll apply a small amount of heat and a small amount of solder to each of the other legs of the transistor. And then we'll move along to the next connection. We're going to zoom in a little bit and let you see that process a little bit more close up. Okay. So again, we apply heat to the leg, we apply heat to the side with one leg, and we lift that part away from the board. Next, we'll apply heat to the other side. We'll lift the rest of the board away. I'm going to use some solder braid and remove that old solder. We'll move to a fresh place 2 or 3 times. Just make sure we get it all. Okay. Once we get that board cleaned off, we'll put a fresh dab of solder. To line up with the pads on the board, we'll apply some heat to the pad that we applied the solder to. And we'll just make sure that that component's nice and flat, lined up with each of the 3 pads. And we'll apply some solder and some heat to each of the other 2 pads. Okay, we'll do that for each of the 4 transistors on this board. Again, we're going to show you a close-up of where those are. This is a new style board. This is the wiring harness connector down at the bottom. We'll see a transistor here, a transistor here, here, and here. Okay, this is an old style board. This is the wiring harness down at the bottom of the board. Those transistors are located here, 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 and here. Next, we're going to take a look at the solenoid board. We're looking for any corrosion. We're looking for any cold solder joints on the electrical connections to each of these 4 solenoids. That would be the large oval-shaped pads here. If we see any of those, we would again apply some heat. This is a large connection. It might take a little bit of time for the heat to flow. After we apply heat and everything melts, we'll apply some fresh solder. The fresh solder does 2 things. It adds rosin to the solder joint, And the rosin tends to clean any oxidation that is, any crystallization that has happened in the solder, and it also causes the solder's viscosity to change, and that it becomes just a little bit more runny than it would be otherwise. And that helps solder flow through the small holes in the circuit board, and it helps it adhere to the pin and to the pad. So we're looking for nice shiny solder joints after we're done here. Next, we're going to look at the board for any other problems. I don't see any cracks. I don't see any corrosion around the connector. I don't see any obviously defective transistors on the board. I don't see any damage to the traces. So I think this is in good shape. If you had a piece of vacuum line tubing, you could flow test these solenoids before you put it back together, but for the most part we don't see problems with them. Every once in a while we see the filter. This is a filter material. I think it's a sound deadening material that causes the unit to be a bit quieter when it's releasing vacuum into the cabin. And it acts as a filter as well. This filter material is some kind of an early, this filter material is some kind of an early 90s foam, and it does tend to degrade over time. If yours is completely falling apart, I would take these metal clips loose. They slide straight up off of this, and I would just clean the solenoids to the best of your ability. Clean the metal clips and put them back in place. Okay. Next, we're going to examine the plastic housing and the vacuum port. What we're looking for here is any obvious damage to these ports. Some of the later model programmers were made with a soft, pliable type rubber, like a silicon rubber coating on this vacuum connector, and in that case, it is possible that these tubes can close up under a heavy vacuum. When that happens, air tends to go out the wrong location. It can go out the defrost vent instead of the forward-facing vents, or instead of the floor. Okay, we're looking for any chewed-up connectors. We're looking for any damage or signs that those ports might be closing up. I don't see any problems here. This looks fine. So I'm going to go ahead and reassemble things. We're going to reinstall the board, making sure that it hooks under the two plastic tabs at the front of the plastic housing. And then we'll replace the two screws that hold the logic board into the plastic housing. Okay, we'll reinstall the solenoid board by reconnecting the electrical connector. We'll make sure there are no pins protruding on this or this side of the connector. We'll hook the bottom edge of the board into the two plastic tabs on the plastic housing. We'll replace the 2/4 inch screws that hold the solenoid board in place. Finally, we'll replace the vacuum connectors on each of those solenoids. And then we'll replace the cardboard back. I just use a bit of black tape to hold the dust cover in place. And that's all there is to rebuilding the programmer module. Next, we're going to hook everything up and see how we did. If you're doing this, you would hook it up to the car wiring harness. I am hooking it up to an in-house test rig that we've built here at Batee.com. I'm plugging in the programmer. We also have a blend door motor. I'm going to plug everything in. The first thing I notice is we have a nice bright display, and it has actual information. The first thing I'm going to do is test to make sure that all of the buttons function. We're going to look to make sure that all of the lights light up. We'll turn out the lights here in a second and show you that. And we're going to make sure all the buttons function. Looks like this is working as it should. Okay, so the good news is we have done our job properly. We see a display on the controller, which means the controller is communicating with the programmer. We're going to test each button just to make sure it does what it should. Okay. It looks like we've done our job properly, and this is working like it should.